Hello and welcome back to Learning Python in 3 hours. Today's section is about data science and machine learning with Python. I'm putting this front and center because a lot of people have started on Python recently because Python has an excellent ecosystem of packages for data science and machine learning. Now obviously that's a very hot topic, whether you're a developer or a scientist, and that's driving you to use Python. In this section, we're going to take a look at how we can handle big data sets and long vectors with NumPy and pandas. We'll talk about introducing machine learning models using scikit-learn, and then we'll conclude with how we can visualize data in charts and graphs with matplotlib. In this video, the topic is handling big data sets with NumPy and pandas. In this video, we're going to talk about what is NumPy and what is pandas. NumPy is good for arrays and array operations. So think about lists of numbers, integers, floating numbers, and other data types. And then we'll talk about data frames, which you can think of it as more annotated and structured data sets loaded into Python. And pandas gives you a data frame object for you to very easily view and select data with data frames. Obviously, this is going to just scratch the surface of NumPy and pandas, but hopefully this can give you basics of what it can do so that you can look at our other videos to learn more about NumPy and pandas. Let's go into our IPython and take a look. If you haven't installed NumPy, it's very easy. It's simply pip install NumPy, and the same for pandas. So NumPy is the core library for scientific computing in Python. It provides a high-performance array objects and functions and APIs to work with these arrays. In NumPy, an array is a grid of values, and they all need to be of the same data type. So if you create an array with integers, all of the array needs to contain integers. If you initialize an array with floats, then all of the array needs to be floats. The number of dimensions is the rank of the array, and the shape of array is a tuple of integers giving the size of the array along each dimension. The canonical way to use NumPy is to import NumPy as NP. You remember the as keyword from section 2 when we talked about importing modules. The very basic array looks like this. So we called the array objects from NumPy, and then we simply feed it at list of Python numbers. Remember, all of these has to be the same type. And we can do things like type A, that's an array, do shape, which gives us a tuple of integers, which describe how long or what's the range of the dimensions according to each dimension. So because our array only has one dimension, we only have one number, and this number is 5, representing the length of the array in the first dimension. We can do things like printing the first element, printing the second element, and printing the third element. And we can also assign one of the elements to an arbitrary number, and we can see that the first element has changed successfully to 100. We can also create matrices or two-dimensional arrays by doing list of lists. So for example, and we can notice that the shape of B is now 2 numbers in the tuple because we have 2 dimensions. First dimension is the outermost list, which contains 2 further elements, both of which are lists. And each list in the element is of dimension 3. You can also create arrays with the conventional functions, so you can have np.zeros, let's say 3. And it'll create an array of length 3 of zeros. Again, this is just feeding in the shape, so we can say, 5, 5 to create a matrix of zeros. We can also do ones the same way, or fill it with an arbitrary number. And one of the more interesting things is then creating a random array where you need to initialize a bunch of numbers with a random number. So what if we're dealing with data where each of the values are of different types and they're not as nicely formatted as something that a NumPy array would handle. So this is where we can use pandas. The canonical way of importing pandas is to do import pandas as PD. So the analogous pandas data type for vectors or lists of data points is series. So we can do pandas.series. And in contrast to a NumPy array, we can actually put more than just one data type here. So we can do 1, 2, 3 and as integers, and then we have 4.0, and then we can have not a number. You can also do things like date ranges. So if we do a date range, we can say it's 2018 March 20th today, and we want 12 periods, right? So it creates a date range, a bit like Excel, right? I think most of you would come in from a background, if you don't know machine learning already, the easiest way to think about this is things that you do with Excel, just with Python. And finally, I also want to talk about the data frame objects, and that's actually the thing that is the most powerful from pandas, where you can have multiple columns indexed by multiple rows of different things. So imagine if we save this date range as dates, we can create a new data frame that had random numbers, as we talked about before. We need 12 periods and then 4 columns, and then we assign dates as the index. Indexed by multiple. This should look very familiar if you were working with any sort of time series data or any sort of, let's say, revenue data or visitor data in your Excel. Representing this in pandas and Python primarily involves using a data frame. And you can imagine looking at a spreadsheet here where you have a column, what is called an index of all the data points. So each is indexed by its date. And we have 4 columns of variables or 4 columns of data where each column is now currently a random number. But if you're using real world data, these would probably be something like number of visitors, number of signups, time of day, etc. The way to persist this, we usually assign this to a variable called df, and we can do things like look at the first 3 rows or looking at the bottom 3 rows. The displayed results to a sensible number of data points. So imagine if your data frame has 5 million rows and that fits on your memory. Using head and tail allows you to understand how the data frame looks like without flooding your terminal with endless and endless pages of data. You can also do things like df.columns, which gives you what are your columns called, and you can do smart things about selecting the columns based on their names. And you can even do statistical summaries like df.describe, where it gives you counts, mean, standard deviation, and percentiles of all your variables. And this is, you can see how it quickly becomes more and more powerful over something like Excel with just a few simple Python calls. So that's a very whirlwind tour of NumPy and pandas. We talked about what is NumPy and pandas. We talked about arrays, array operations, and data types in NumPy. And we talked about data frames, viewing and selecting data with pandas. I hope that this gives you enough information about what these things do within the data science ecosystem so that you can go on and maybe find a video that specifically focuses on these libraries and for you to kickstart using Python in an applied way.